deal, but we'll go with it. Cool. So my name is Elliott Hauser, and I work at a startup called Trinket. We're Python in the browser for teaching. And this past academic year, I taught Python at UNC Chapel Hill. I'm now on leave from my PhD there, focusing on Trinket. And my kind of fun slide is totally spoiled. Let me see if I can at least get the animations to go, because there's 3. So why do we teach? Like Python. And I just found this on the internet and kind of customized it. It's the weirdest image ever. But also the government is like everyone should code, right? We're being good citizens by increasing Python knowledge. It's also fun as hell. If you've ever floated around using import anti-gravity, it's the most fun thing there is. And seeing your students import anti-gravity and start floating too is really fun. And it's the best way to get rich quick. Not really. Just like Huel here, people who teach Python are often right next to the money without actually having any of it. But the cool thing about the Python community is that a lot of developers who make stacks of cash actually devote some of their time, often with the support of their employers, to teach Python, which is awesome. And teaching Python is a valuable job skill, setting people on that path for a career in tech. All right, that was my fun animation. So here we see a map of wireless coverage from Verizon, AT&T, and people who need to learn Python. This is just the US, and it's not to scale. But there's a lot of people who need to learn Python. That means we're going to be doing this over and over again. When I talk about stacks, that means tools that you can use over and over again. You can collaborate on others. They're kind of plug and playable. Just like in the beginning of the web, most websites were coded by hand. And then after 15 or 20 or 200 hand-coded websites, you're like, maybe we could automate some of this. Maybe we could share with others. Maybe we could build structures to get us going faster, make us more effective. That's what I mean by teaching stacks. We're going to be teaching a lot of people over the next coming years, Python and tech in general. So let's build tools. So a coding stack. Who's heard of Young Coders tutorial? Oh, wow. No one. OK, Young Coders tutorial is really awesome. You can Google it. It was started by 2 programmers, Barbara Charette and Katie Cunningham. I'm not sure if it was the first time that they did it, but they did it to kind of much aplomb at PyCon 2013. And basically, they brought a bunch of kids in the room, gave them Raspberry Pi computers, and taught them how to make a basic game using Pygame, just like we saw in the previous presentation. This is their teaching stack. They use GitHub Pages to, well, kind of at the time they were using GitHub to kind of share PowerPoint decks back and forth. It was the very beginning. But they use GitHub to share these materials. They're accepting pull requests into these. It's essentially a 1 to 2 day workshop for kids. And they've made all these materials and all the code, more importantly, that go along with these workshops open. Really awesome, and I think pioneers in the space. By the way, they have inspired lots of other people to teach workshops for kids using these techniques and using these materials, which is exactly the purpose of this. Let other people in the community do what you're doing quickly. So here are the general parts of it. It's kind of a bad analogy a little bit, but we have server client, roughly. And there are other things you have to do, obviously, to get prepared to teach and to actually teach. But the big things are you need to get your students some materials to look at during class. Later on in this session, I'll use git clone for you guys to get the materials for this class. Depending on your student population, that may or may not be a good idea. Depending on your student population, they may or may not have a coding environment. This means Python running. This means a text editor that's appropriate, that's not Microsoft Word. You really, depending on your student population, this becomes more and more of a consideration. Then I'll talk a little bit later, I think, about best practices for the instructor's coding environment. But that's also a part of the teaching stack. What are you going to actually do in class? In a formal classroom setting, this is graded assignments. In a workshop type setting, this is what are you actually doing? Hands-on, what's your project? And then materials, this is what are students going to read ahead of time to prepare? What do they need to know? Is there any background or reference material, et cetera? Here's another teaching stack. Has anyone heard of software carpentry? Sweet. Software carpentry, another pioneer for not just Python education, but I think tech education in general. Supported by the Mozilla Foundation. I think Sloan got in on the action lately. And they're teaching, they've taught hundreds of workshops to scientists, PhDs, and researchers about how to use software tools to do better research, to do reproducible research, to do open research where you can share your code. Very cool program. And I think the most successful organization today teaching with open materials. Really cool stuff. And in the beginning, they had all kinds of problems. At the PyCon 2014 Education Summit, a recurring theme was how difficult it is to install Python on an arbitrary computer. On some computers, it's fine. But in a room of 30 people, there's going to be someone with Windows XP, or there's going to be someone with, something weird. A lot of the Mac OSs ship with Python 2.6. It's just a mess. And it took them a long time to find out, I think, best practices here. But they're very well documented on their wiki, troubleshooting about how to get Anaconda, which includes a lot of the common Python packages, especially for data analysis. And that works for them, which is awesome. They use a GitHub repository for their boot camps, and they distribute that. If you go to software-carpentry.org/v5, it's the latest materials. That will become, I think, a little bit more user-friendly. But that's also a GitHub Pages site that instructors, when they're teaching, can fork and customize with all of the kind of vital signs of the workshop they're teaching. Really cool, and it's been great to see them the past 2 years into a really efficient, really effective teaching group. So from the two examples that I talked about, I think there's some best practices. Certainly plenty of other best practices for teaching in general. But all of these materials are up on the web for free. I think the days of closed content for teaching are numbered, and it's just so much more fun to be able to share our materials and talk about them just like it is for code. The other thing that these workshops have in common, software carpentry is increasingly requiring this of their instructors, is that the instructors use the same coding setup that students do. This is less important for expert programmers or anyone who knows what Emacs and Vim are, right? They have their custom setup. OK, fine, you're ready to go. But for the vast majority of that big green map of the US, they have no Emacs and Vim are. They probably don't have a favorite text editor, et cetera. They need to see the same thing on this screen as on their screen. And then this one is the hardest. Not using open materials, because a lot of instructors pull stuff down off the web. But it's using materials that someone else made and then kind of contributed back. It's very similar kind of first mover problem that we had in open source software, where you're really going to go get that framework and customize it to your needs, or you're just going to write your own. And then if you write your own, you're really going to share that code. And if you share that code, are you really going to make it general enough to meet someone else's needs instead of your specific needs? And I think software carpentry is doing the best at this, but there's still lots of room for improvement. And so I think this is kind of the opportunity. So best stack, same as web stack or programming languages, frameworks, whatever. It depends, which is not a sexy answer, but it depends on you, and it depends on your students. So I'm going to show you in a sec the teaching stack that I've used. And I can adapt it to teach all of these groups of students. I'll advocate for it. I'll tell you why I chose it and why I like it. But a different instructor could use a different stack to teach each of these groups just as successfully as I do, based on their style and how they present it. So I've come up with a completely unscientific 5-step rating scale. And also, I've forced these into polar opposites, even though they don't always line up exactly. But I think this might help us just do a basic histogram of these different coding environments in particular. So materials access and things like that, I'll have some links at the end. We're going to zoom in on this. When you're teaching Python, what are your students coding in? That means what's their text editor and what's their kind of Python runtime. So for the Young Coders tutorial, It was Raspberry Pi and IDLE, which ships with Raspbian, the custom version of Linux designed for the Raspberry Pis. It's really slow to set up, and it's designed to not require an internet connection, which actually can be a benefit in some locations. This is the big thing, though. The Python Software Foundation gave Young Coders Tutorial a grant to buy a bunch of Raspberry Pi computers. Has anyone seen the Raspberry Pi? Familiar with it? It's a little system on a chip computer. It's like a circuit board, same processor as some cell phones, and it's really cool. They bought a bunch of those and then gave those to the kids, to the attendees. That's great if you can get it. You can get a couple $1,000s. They're only $35 a piece, but times 30 plus monitors, plus keyboards, plus mice, etc. It can be slow and expensive. It gets down to the free paid spectrum where the software is entirely free and open source, which is awesome, but you do have to buy the hardware. But I think the Raspberry Pi is an excellent choice because of commitment to open source and the wonderful educational community that's grown up around it. It ships with a program called Scratch, which is great for younger kids. It's not one of the common misconceptions I think about Scratch, little diversion, is that it's simpler as a programming language. Scratch was designed for kids who have trouble typing, for any student population where typing is a problem. And that should be just as much the case for issues. So think about that in terms of Scratch. Any students typing skills, you can still go over the basic concepts with Scratch. Cool. Nitrous.io will go into this, but this is kind of, I think, the value of that histogram. I think it's kind of opposite, depending on different goals. It's really fast. You just log into our browser, sign up for free, and you're off and running with Ubuntu server. It's cloud-based. They have a free tier, although it is a proprietary product. And they contribute as a company to open source, but the this itself is not open source. And there's really not much of a teaching community. I kind of am it. So I gave myself 1 point. Anaconda, similar to the Raspberry Pi setup in that it's got this great free open source community-based setup. It's actually pretty good as far as installing Python, cross-platform support, things like that. But it's designed to be run for your local machine. Jython is something you might not have, this Jython environment for students, might not have heard about that. I have.
Anaconda, that's, I think, cloud-based, right?
Yeah, absolutely. So this could slide over if you're using kind of the cloud version of it. Anaconda is provided by a company called Continuum, and they have a lot of cloud kind of services. Are those free? Do you know?
Lucari, yeah.
That's all. Excellent. Cool. Well, maybe that dot needs to move. Jython environment for students. Jython is a Java virtual machine interpreter for Python. This is an IDE, cross-platform IDE, developed out of Georgia Tech. It's primarily great for kind of CS 101 university students and kind of the whole CS track and undergraduates. Thought I'd mention it here. So now we're going to go deep dive into my stack. I use GitHub Pages, which is great if you're also teaching people who are kind of undergrad and up, and you want to include GitHub in the curriculum. So my students in week 1 forked our class site, added themselves to the roster, and submitted a pull request. And that was part of the kind of activities. GitHub is kind of unique in that respect. And then they saw it show up on their website. It was really cool. Coding environment, I'll get into Trinket. Trinket is just kind of the basics of Python in the browser. I use that to get kind of basic, anything in a standard library, essentially, done without installing software, without setup. And then Nitrous is what I used. Nitrous is great as long as you're not doing desktop application programming. It's best for web programming. Codingbat.com by Stanford professor is excellent kind of practice. The rough analogy is like batting practice. It's like little in the browser exercises. InteractivePython.org. All of these, Trinket, CodingBat, and Interactive Python use open source technology called Sculpt. It's a JavaScript interpreter for Python code for the standard library. And all very interactive, great kind of for students to get going quickly. This is what Nitrous looks like. This is full Linux terminal, Ubuntu server down here. And this is a web IDE. We'll dive into this in just a sec. Trinket is essentially embeddable iframe wrapper around Sculpt and some custom technology that we've added to Sculpt. So this is interactive without logging in. Students can change the code. Each student gets their own copy. And Flask. Flask is a great choice, I think, for teaching the basics of web development. It's incredibly simple. And I'll show you some code in just a sec. So I try to use best practices. Materials are up there for free. I try to use the same thing that my students do. And to the best extent possible, I try to reuse and contribute to these existing resources. So you guys might have seen this when I was editing. It was kind of my big surprise. So now we're going to put Python in your Python so you code while you code. Cool? With Trinket, we get Python in the browser interpreted by JavaScript. With Flask, running on Nitrous, we get just a basic web app. It can serve up the iframe that Trinket then serves the Sculpt in, and let me show you. So Nitrous IO, you guys remember them. I'm signed up. I have a premium account. You get enough for just a basic virtual machine with a free account, which is awesome. And you can get more. They have this like fuel called Nitrous, N2O or something. And that's what you essentially buy if you upgrade. You can also get more by sharing, stuff like that. I'm not affiliated with them at all. I just really like them. So this is my actual dev box up here. You can see the specs on it. You can SSH into it, etc. I'm assuming it's an AWS virtual machine. I don't know for sure. But so following my kind of dictum of having the same coding environment as your students, I want to make a new box. And so if anyone is signed up for Nitrous, you can follow along. You should see exactly what I see. They have some preset stuff. You can go through and install all this stuff yourself, or you can click a button. And really cool is you can just copy the GitHub URL of the repo you want to clone when you create the box and create the box. So it'll take a while to provision. While we're doing that, I'll pause for any questions or comments, and then we'll get back hands-on and to our Python in your Python so you can code while you code. Any questions? Does anyone here use a cloud development environment? Like Nitrous or Cloud9, what do you use?
Actually, like I'm tech ops, so we use like AWS and OpenStack.
Oh, cool. Yeah, perfect. Yep.
Maybe a little general, but as far as like the learning objectives with your students, it looks like you're probably maybe purposefully skipping over a lot of the sys or the DevOps side of things. Is that ever important to be teaching the security and the file system and the network to folks, or?
You know, my student population has been beginners, often adult beginners, often beginners with experience in other languages. And so I tend to skip over that stuff. Like, the closest we get to DevOps is like deploying to Heroku.
Yeah. I mean, I think a lot of beginner students don't even know what the file system is or what a file is, and the connection between the GUI version and the command line. So, forget the DevOps term, but like,
Sure.
I'm curious on the learning objective side, like the relative value of teaching people like coding in the abstract versus anything to do with the command line or how computers work on the network and the internet works.
Sure. Well, so for my class at UNC, when I had a semester along with the students, we did go over the command line and kind of resolved any confusions that were there. For workshops, I teach workshops for like K-12 teachers, the basics of Python, and we don't get anywhere near that stuff because it's about maintaining the excitement and essentially giving them the confidence that they can teach themselves a lot. So different approaches for different classes. Yeah, it was a great one. Yeah.
What does Coursera use for your online, especially for grading assignments and also the online video that they have?
Yeah, that's a great question. I know that Code Sculptor is kind of their wrapper around Sculpt, the the JavaScript Python interpreter. And I'm not sure about the actual kind of assessment process. I haven't been in a Coursera course. I'm not sure. I don't think Code Sculptor itself is not open source. We've been asking them to haven't yet. Some professors out of Rice. And it's not, I think it's just they don't feel like the code is ready for other eyeballs. But as far as the actual like LMS type stuff of managing assignments, I'm not sure. All right, so here's my Trinket box. This is my Ubuntu server command line down here. And by the way, in terms of teaching file structure and stuff, this is awesome. It's the thing that they're used to with this right underneath it. And so when I cd workspace and ls, I can show, okay, that's the same thing as what's in that folder, cd yo dog, ls, and it's the same files. And like I haven't found a better way to try and teach this. We got our 5-minute warning here, so let's see if we can make a web app. First of all, let's see what we got in this web app. Python yo dog. One thing with Nitrous, for those of you who are going to do this, it requires the zeros instead of the 127 stuff. So you have to hard code that in projects you find sometimes. But we can just preview this page. Hello world. Man, that's boring. So boring. I'll do this. I'm right in the middle. I'm right in the middle of something, guys. So those of you who are following along, I'm going to go to trinket.io/turtle, and we have just a little interactive trinket here. In the startup is X for Y type thing, we're kind of like YouTube for interactive examples. That's how you think of Trinket. So you can play it, you can customize it, which is on YouTube. So that's kind of big apple pie colors, right? So we've customized this code. I'm going to grab the embed code off of it. And assuming that my box is reloaded here, I'll show you the visual IDE. So here's our tiny Flask app. I'm sorry, it's horrible. Nitrous and Trinket both need better big text support. But we import the big Flask object, make one. We didn't really get into decorators in my class, but Flask is it's just like, well, that's a decorator. All you need to know is that when you go here, you get this. So app.route, when you go to the root of the server, return, render to the template, and run this thing. That's where I hard-coded the zeros. And in templates here, index.html says hello world, and that's boring. So instead, we replace it with this and save it. Oops, and my process has died, so I'm going to cd workspace yo dog. Beautiful. So now I'm up to my web app, and I have a Trinket here. Python in my Python, so I can code while I'm coding. So this is just basically a nice dev server. If you have a premium account, the boxes will never shut down. If you have the free account, they'll shut down after like 30 minutes. So this is not like for production, it's just for seeing what you got. And boom, that's it. Let me race through in the last minute or two, the rest of these slides. These are not links, but they will be when I post these. Questions or stack suggestions? I think we already did that, but any questions?
Did you already mention if your slides are like open somewhere on on your website or something?
I will tweet the link.
Okay, perfect.
And what's my Twitter handle? There it is. Thank you, guys. So go out and teach Python. Find a group like Girl Develop It, Software Carpentry, PyLadies, absolutely, who are doing these great workshops, and lend your knowledge to them. You can get students up and running really quickly. If you want to just teach the basics, embed a bunch of trinkets showing different things like what a for loop is, what data structures are, things like that. And you can, that's what I did with UNC. We spent the first month and a half or two in the browser, and then we moved into Nitrous and started developing real applications. And it really worked well because the students knew what they were doing. They were familiar with the concepts by the time they really got hands-on. Yeah?
The blurb also mentioned the IPython notebook.
Yeah.
Essentially doing that and how it fits in.
So I didn't use it for mine. It's absolutely the best choice for any kind of scientific programming, and essentially intermediate on up, where you can rely on someone to already have Python installed locally, and you just need to get them this exact code and then start working on it. Visualization, stuff like that, it's absolutely the best. But I focus on beginners and teaching on a Chromebook, web development, stuff like that. So not a tool that I use. Awesome. Thanks, y'all.